And we are going knowing the time complexity and the space complexity here. So time complexity is the function that describe how long an algorithm takes in time of the quantity of the in the term of the quantity of input it's received, so time required. In the space complexity we have the function that describe how much memory an algorithm required to quantity of its method. So it means the time required is time complexity and space required is for the space complexity. Here you can see that data structure is like a divided into linear data structure and non-linear data structure. Then there is array for the non-linear data structure, stack are in the linear data structure, q key into the linear data structure, and linked list are in the form of the linear data structure. Now you can also know that here you see that non-linear data structure like graph and tree. Linear data structures are easy to implement because computer memory is arranged in the linear way. Its example is array, stack, queue, linked list, etc. Actually, if we talk about the best case, so best case is a function that which perform the minimum number of the step on the input data of an element. Worst case, the function which perform the maximum number of the step on the input size for the size n. Average case, the function which perform the average number of the step on input data for the elements. If we talk about the popular complexity analysis of the algorithm, so first one is big O notation. So big O notation, we define an algorithm worst case time complexity by using the big O notation, which determine the set of the function grow slower than the same rate of as expression. Furthermore, they explain the maximum amount of the time an algorithm required to consider all the input values. If we talk about omega notation, so omega notation is like it's define the best case of an algorithm time complexity of the omega notation. Omega is denoted like this. So omega notation define whether the set of the function will grow faster or at the same rate as expression. Furthermore, it's explain the minimum amount of the time an algorithm required to consider all input values. Now talk about theta notation. So theta notation define the average case of an algorithm to time complexity. The theta notation define when the set function lie in the both expression and omega expression. Then theta notation is used. This is how it be define a time complexity average case for an algorithm. Now we are talking about measurement of the complexity of an algorithm based on the above three notation of the time complexity. Three are the case of the analysis to analyzing the algorithm. First one is your worst case analysis, mostly used. In the worst case analysis, we calculate the upper bound and the running time of the algorithm. We must know the case the q is a maximum number of the operation to be executed. Number of the operation for linear search for the x, and this is would be onion. Best case analysis, so this is omega notation. In the best case analysis, we calculate the lower bound of the running time of an algorithm. We must know that the users that the q is a minimum number of the operation to be executed. In the linear search problem, the best case occur when x is present in the first location, the number of the operation in the best case constant, so the time complexity is the best case would be omega. Average case analysis, the average case analysis is we take the possible input to calculate the computing time for the all the inputs, sum of the calculated value and divided by the sum total must be known as a predict cases. Like it is denoted by the theta, so it's like that.